Professor Carey is here.
Okay, sounds good. I think we're gonna get started. Uh, all right, good afternoon, Golden Bears. My name is Ricky Vides. I'm the academic advisor for Mechanical Engineering Department. I'm very lucky to be in your presence this afternoon to welcome the class of 2025 and class of 2023 to our family. Mechanical engineering is a beautiful place to have an academic experience. And I'm gonna walk you through some geographic and historical places of interest that will hopefully help solidify your decision to come to the University of California. One of the themes that I'm gonna be building off today is the cornerstone theme. You all are the reason why our university is as great as it is. You all are the ones who take the exams, who publish the papers, and put your best foot forward in making society a better place. So you all are an example of the new cornerstone that's being laid for the future that lies ahead of us. This week is known as Cal Week. It's the artist formerly known as Cal Day, when we used to have one large open house. But hopefully these week's events will give you the information that you need in order to have the best balanced decision about where you'll choose to spend the next 4 years of your life. I want to start off by celebrating the fact that we went co-ed 150 years ago. And this is a photo of our first graduate in mechanical engineering, our first female graduate, Carolyn Willard Baldwin, who graduated in 1892. Shortly after, she was the first author and publisher of the photographic study of arc spectra. And she's actually the first woman to earn a PhD from an American university at Cornell. If you're interested in learning more about women and their contribution to the mechanical engineering department, I'm gonna allow for folks to take a screenshot or jot down these tiny URLs where you can learn about all the contribution that women have made throughout our history. Like I mentioned earlier, I mentioned that I wanted to take folks on a historical point of interest. This is actually an image of Oakland in the 1850s when we were just two buildings and we were called the College of California. This building these two buildings actually no longer exist, but as a reference point, they're off of Franklin and Broadway in downtown Oakland. This is our Founders Rock, which is where our founders drew up the charter for the University of California, not too many years after the 1850s. Eventually, in 1868, we moved to what you would consider greener pastures at the Peralta Ranch, which, as you can see, wasn't occupied by much back then. You can see off in the distance the Greater Bay Area, Marin and Mount Temple Pius. You could even see a bit of a fog, honestly, even though it's a historical image. This is a photo of campus today, not too far from where that image was taken, right next to our university, which is actually the greatest collection west of the Mississippi. This is a bird's eye view of the Campanile, which is one of the more inspiring places on campus. And I strongly encourage all of your families to make a visit up to the tower and really embrace the moment of being accepted to the University of California. Like I mentioned earlier, this is the theme is the Cornerstone theme here. And this is one of our former presidents, President Wheeler, and the student body, people who encompass leadership on our campus, laying the cornerstone for the Campanile. Other points of interest are libraries. These are absolutely beautiful. On the left, you see the Morse Reading Room, which is actually a place of leisure. Technically, it's by policy and by practice that people aren't allowed to study or complete assignments in there. But every now and then you see a Berkeley overachiever completing an assignment in there. But it's meant for you to relax and embrace the setting. To the right, we have one of our great reading rooms, which actually has the great book philosophers stitched on the wall. The North Reading Room is one of my favorite places. Also, we have the library, the music library. But students go beyond just the classroom and beyond the library. This is an example of our competition teams that are competing on a national level, building solar cars themselves, machining them, manufacturing them, designing parts, and eventually competing against other universities. We also have a Formula SAE team as well. This is an example of our group, the Robo-Bears, which actually serves a dual purpose. They are decal facilitators, so they have an instructional role in our department, both as students and instructors. And they are also a student organization that competes nationally as well. Just thought I'd show you some faces so you all can see who embodies our student body. I'm really excited to be joined by our leadership team. I feel very fortunate to work with such an incredible group of educators, people who are some of the most brilliant scientists in the whole entire world. And I'm gonna just introduce Carolyn really briefly, which is our Student Services Director. She's been with me since the beginning of this presentation, and I'll have her introduce the next person as well. So I'm gonna hand it over to our Director of Student Services, Carolyn Clark.
Thank you, Ricky. And I also just want to say congratulations to all of you. This is so exciting, and we're so excited to have you here with us. And I know that it's been a very unusual year, competitive year, and it took a lot of effort just to get your applications out the door. I have a son who's a senior in high school right now, so I do know. And we are just so thrilled to have you here. And I will just, I won't take up a lot of your time, but I just want to encourage you to ask a lot of questions and don't be shy about that. It's really important to get as much information as you can. And we hope to see you in the fall. So I'm going to turn it over to our department chair, Professor Roberto Horowitz, who is a triple bear himself.
Thank you very much, Caroline. My name is Roberto Horowitz, and I would like to, I'm currently the chair of the department, and I would like to welcome all of you. Congratulations for being accepted to mechanical engineering at Berkeley. And I'm going to give you a little bit, I think Van is going to do this, a little vice chair of instruction later on, but I just want to emphasize that this year's class is actually the largest class of accepted students that we have ever received, almost by double. But more importantly, the admission was the admission requirements were almost as strict. So the admission rate, just so that you know, it was around 9%. So this was one of the most competitive majors to get into Berkeley. And I want to sincerely congratulate you, all of you, because you must all be wonderful students in order to get in. Another interesting thing that I want to point out, that this year's, not only you guys are going to be the largest class that we've ever had, but it's also the most diverse, and by a long shot. We have the largest percentage of female and underrepresented students ever. And in fact, I want to make a plug for all Latinx. I'm myself a Latinx, go Bears, that we have the largest Latinx representation ever at Berkeley. The other thing I want to, I just want to give you a little bit of a personal note. Many of you are either coming as freshmen, frosh, I guess we use that term now, or maybe transfer students. I came myself, as Caroline and Enrique said, 46 years ago, if you can believe that, almost at the time that Founders Rock was created. I came here as a transfer student. So I was myself a transfer student from Venezuela. I was a sophomore, and I was blown away by Berkeley. I mean, I was on one hand really terrified because this place was so difficult and so challenging. But on the other hand, I was thrilled because the professors and the materials, and more importantly, I'm going to tell you the secret. The secret of Berkeley is not the faculty, which is excellent, not the staff, which is excellent, but the students, which are superhuman. So all of you are going to be surrounded by your peers, which as a group is an amazing group of people. So I came, just to finish my story, I came here as an undergrad, graduated from Berkeley, and immediately the next semester, I graduated in December and became a grad student in January. And then after that, I did my PhD, and 1 year before I finished my PhD, I got offered a position as a faculty here at Berkeley. So I actually, my last year as a grad student, I was actually teaching some of my peers, and I was actually teaching a student myself, a graduate class in control systems, and I became a professor. And I've been ever since here. So I'm always joking that the university could not get rid of me. So they had to first accept me and then hire me. And now I'm chair and soon to be ex-chair. I'm going to be stepping down as chair on July. And I'm going to be succeeded by a wonderful person, Chris Dame, which is I call him, I always said he's younger, smarter, and nicer than I am. So he's an improved version of the chair. So without further ado, I'm going to introduce my very capable and good friend, Van Carey, which have been working for me and tolerating me for many years, now as my vice chair of instruction. Go ahead, Van. Thank you.
Well, thank you very much. I'm Van Carey, the Vice Chair for Instruction and Mechanical Engineering, and I work in coordination with the Student Affairs Office and Carolyn Clark and their team to support the instructional program here in mechanical engineering. As you've been told here by the preceding speakers, this is a spectacular place to have an educational experience. Just to give you some statistics to support some of the things that have been said, our accepted applicants have an average GPA of 4.52. We have about 30% women in our student body in the College of Engineering. About 24% are international students. There's 245 faculty in the College of Engineering, and 76 of them are members of the National Academy of Engineering. We have 24 professors who are recipients of the Distinguished Teaching Award, which is the most prestigious award on the campus for teaching. Within mechanical engineering, we have a total of about 700 undergraduates. In our graduate program, we have about 330 students that are in master's and PhD programs. We also have transfer students representing 46 community colleges from across the state. And we do consider our transfer students to be spectacular, and they always come here and do a terrific job. So we fully expect that you'll all adapt and fit in here and do just great. One of the things I like to say about Berkeley is that I think this is spectacular, not just because the College of Engineering and Mechanical Engineering are terrific, but also because you're going to have an experience of interacting with students all across campus who are involved in top-notch programs. Being able to take courses out of the humanities and the physical sciences from students that are top-notch in those fields. The intellectual energy of Berkeley is just terrific. And I think that you'll find that it's inspiring to be here and work amongst people that have such high levels of commitment to excellence and performance in these different fields. So with that, I think I'll wrap things up here. I'm going to turn things over to Professor Grace O'Connell, who is our Vice Chair of Equity, Diversity, and Inclusion in the Mechanical Engineering Department.
Hi, thank you. I want to, echo my colleagues in welcoming you here to the ME faculty, and congratulations on getting accepted to Berkeley. I know it's been an extremely challenging year with all the online education, but on the one hand, it's nice to be able to see you all here virtually in our Cow Week, as we're calling it. So I was asked to talk a little bit about, we have a flow chart for, directing students through our curriculum from your first year to your final year, or if you're a transfer student, you're in a very compressed time frame. What does the 4 to 5 semesters look like? We have this flow chart that's on our website to guide students, and really you could print it out and have it and just mark off everything just to make sure that you have all the courses that you need to graduate. A lot of the courses, a lot of the ME courses that you see are in your upper years, so junior and senior year. But really, there's a strong foundation and a reason why we have this flow chart set up in the way that we do, in the order that we do. But it's not strictly that you have to take classes that are set up in the semesters guided. So I was going to walk through just kind of giving a brief background as to why we have all these arrows in different directions and how they build up on each other. So starting from Math 1A, you have calculus, and then that builds up to Physics 7A, where you learn about how you can use that, that calculus to estimate the distance a projectile will go when you throw it at a certain angle. And then we finally get into mechanical engineering courses. C85 is how do we apply this to statistics? And then we add even more to that. So we're building up on our foundation on, I think of it as building backwards of an onion, building more layers. So once you get into the junior year, you start to really think about, now you know the math behind things, how can we actually design things with that math in mind? So 108 is our materials course. And once you have that foundation, then you have openings to a whole bunch of technical electives and your senior design project. So your senior design project is really where you put everything together in the last year and you actually build something and put it on display at the end of the semester. So what does this really look like from calculus to the technical electives? And I have a couple of examples here from the technical electives that are available. And there's many, many different types of technical electives and different groupings of those. So as I mentioned, Math 1A is calculus. Some students will have AP credits for this and AP out of this, but if not, it's already embedded within our curriculum. And then how do you apply this calculus to being able to understand how hard do you have to kick the ball in order to get it to the goal line? And this is where then things start to get into more engineering. And this is similar for civil engineering as well as for mechanical engineering. You'll see a lot of these cantilever type of examples. If I were to apply 800, this is 800 newtons, but for example, if you were to apply an 800 force pounds, what are the forces that are applied to this joint and this joint? And if you were to create something like this, you could build it yourself and then test it out by trial and error and see if it's able to handle that. But you don't really want to go through all that trial and error. We actually want to know what are the best practices, what are the equations that we can use to predict what is the force that I need to withstand at this joint C. So that's what you would learn in C85. I have this incorrect here. This would be 108. Once I know how much force I expect here, what kind of material would I want to use here? I know I probably don't want to use a small plastic component if it's 100 or 800 forces or 800 pounds, but I want to use some type of strong, sturdy material like a metal material. Well, what kind of metal material, and how do I want that metal to be treated? And so that's the type of content that you would learn in your junior year in 108, the appropriate material selection. And there's a lot of things that you have to balance in this decision-making process. Not only do you want it to be strong enough, but how easy is it to manufacture? How costly is it per price? Because when you go to large scale, even differences of small pennies will make millions of dollars of differences for a large company. For example, if you think about the number of phones that are made every year by Apple, those pennies really add up. And here's an example of how one of these seemingly unrealistic cantilever type of equations or examples that you might see in your sophomore year is actually really applied in real life scenarios. So this is a glass walkway that was constructed over the last 10 or maybe 15 years down at the Grand Canyon. And it's a glass walkway. And after you have Physics 7A and C85, you'll understand why was this designed in the way that it was designed to be able to withstand those bending forces. And the materials that they were selected in particular for this glass walkway, and is it really glass? So once you get those foundations, then you're really opened up to we have in the curriculum open slots for 5 technical electives, and you can take them in areas of ocean engineering, aerospace engineering, biomechanics, or sustainability and energy. There's a lot of different variety in options. And the one that is required is our mechatronics class, ME 102B. And I have, these pictures are from my class called Designing for the Human Body, where people actually design things that interface with the body, like biomedical devices, but external, only external devices. But even in 102B, you might create something that looks similar to this. It's really designed by the students, what they want to create and what their team wants to create. So I would also say that where you're going to get a lot of help is from your peers, your other folks, and other students that may be 1 or 2 years ahead of you. And this is a nice flow chart. So we have the ME flow chart from the department that I showed you, but the students actually created their own flow chart. So I thought I would mention that as well, because peer-to-peer interaction is where a lot of students get help in terms of deciding what are the technical electives that are interesting to take, or that are more hands-on, or that have more computational, depending on what your interests are. And so these are all the different areas that we have technical electives in. So your junior and senior year, you could select a couple from each one of the categories, or maybe you take many of your courses in design or biomechanics and mix and match, basically. So I wanted to highlight here ASME, which is the American Society of Mechanical Engineers. That's the base society for mechanical engineering students. And the other area where students often get suggestions, I would say, is from the Engineering Student Services. And this is, you have folks that you can go to within mechanical engineering, Carolyn and Ricky, but then there's also mentors and guidance at the college level, and that's the Engineering Student Services, where they even offer support and tutoring for classes like E7, Physics 7A, some of the fresh and sophomore level courses. So one thing that I've heard from students over the years is wishing to have more engineering courses earlier in their undergraduate career. Because as I mentioned, a lot of the ME courses are really stacked junior and senior year. So I wanted to talk a little bit about how you could actually get more of the hands-on stuff early on. So in the first year, we do have E26 and E7, and these are not called ME courses, but they're E for engineering. So they do give you some introduction into what engineering would be like and different ways that you can apply engineering. They're both software-based courses. E26 is computer-aided design, CAD, where you can see how you can create an idea from a sketch into a 3D object on your computer. And then we have MATLAB E7. So that can be an introduction to programming, or some students also take additional programming courses during their time here as electives. Once you're able to create an idea and put it on your on the CAD design, you could actually then 3D print. And one of the things that I really want to highlight and point out to for students is Jacobs Hall. We have a handful of maker spaces on campus, and Jacobs Hall is one of the most common ones for the mechanical engineering students. They have 3D printers, they have laser cutters, they have a machine shop or a wood shop there, and an electronics shop, basically anything, and even a sewing machine. So anything that you would need to be able to prototype something. A lot of student clubs use this facility as well. And one way you could apply your MATLAB computational skills is not only just in the traditional building objects, but how do you do data analysis? So this is from one of the assignments that I gave when I taught E7, was if you've ever had an MRI, they take image slices in one orientation, but sometimes you actually want to look at the brain in the other orientation, and you can do that digitally, and you learn how to do that in MATLAB. So where can you get the hands-on experiences that are related to the ME courses, but not directly in your ME courses early on? There are many design courses that are offered through Jacobs at all different stages, every different year. So I would highly recommend looking through that, as well as getting involved in different student organizations. So some of the ones that I have highlighted here, there's a competition club where they create a concrete canoe. So I've talked about appropriate material selection, and it may seem like a very poor selection to use concrete, but that's the whole idea of this, is how do you make a vessel that actually floats and that can move quickly through the water. More in terms of working with under-resourced communities is Engineers Without Borders, and they work internationally as well. So they raise funds to do humanitarian efforts in sustainability or whatever that current year project might be. They weren't traveling this year for obvious reasons of COVID. And then Enable Tech is a group that actually works with physically disabled members of the Berkeley community, the city of Berkeley. The city of Berkeley is actually a city that is very accessible for physically handicapped folks. And so it's a way to engage not only with your peers in the engineering, the College of Engineering, but as well as peers throughout the college or throughout the campus and throughout the city. And then robotics at Berkeley is another one that was actually, both of these were started by ME students in the time that I've been here at Berkeley. And then a couple other ways that you can actually get hands-on experience that I just want to let students know about early on is through research. So a lot of the instructors that you have class with also conduct research. So they have graduate students in their laboratories, and those graduate students often mentor undergraduate students. So that's a way to get hands-on experience too. And we are directly neighbors of the Berkeley National Lab, which is another location where a lot of research goes on. So I'll stop sharing. That's kind of a brief overview of what it might look like going from your first year to your fourth year, or if you're a transfer student, really you come in and you're already embedded into the mechanical engineering courses. You have a lot of mechanical engineering courses in the 4 or 5 semesters, and some ways to get involved with hands-on work. And I'll pass it back to Ricky. I think we have time for Q&A here.
Yes, we do. And we're doing absolutely great on time. It's 4:35. We have about 20 minutes for questions, and we're going to be transitioning to an alumni and current student panel shortly after that. So feel free to speak out loud and ask your question, raise your hand, and we'll call on you, or you could put it in the chat. So we'll do our best to follow it. So one question that we have here is, I think Dr. O'Connell answered this, but it was a question about what's the distribution between hands-on courses and theoretical lecture-based courses? I'd say that there is a little bit of an even split. If you consider E7 and potentially an extracurricular application to that, a hands-on experience, that's something that could potentially be something that you work into your curriculum. I'd say the physics and math courses do tend to be a little bit more theoretical, especially physics. However, there are some applications that are presented there as well too. Courses like our manufacturing course, which is E29, tends to also have a little bit more of a hands-on appeal as well. Somebody asked if you could take C85 as a first year, and what other courses can you take as a first year if you have AP credit? That is all very case specific, depending on what you earned for an AP credit, and also whether or not you choose to decide to utilize that. So some people potentially test out of Math 1A, which is equivalent to AB, or they test out of BC, and sometimes they start in advanced math, which is either linear algebra and differential equations or multivariable calculus. It really is case specific, depending on how strong you feel your knowledge acquisition is in that area. Some people would say that starting Berkeley halfway through a math series could be potentially difficult. However, we have students who have also excelled in those areas as well too. So I think just making sure you go to the math department, you can do a math diagnostic there and get a feel for where you would be at in terms of your math level. And it's also not so much of what you've taken and what you've passed, but also what you remember as well too. So some folks haven't taken chemistry in a significant amount of time, and brushing up on your chemistry if you plan on specializing in thermodynamics or in heat transfer. Those are all really important things to think about as you're transitioning into your first year. They asked, Akshat asked if what software do we use in E26?
I already answered that.
Okay, awesome.
SolidWorks. Yeah.
Maybe you could read off the answer for the recording.
Oh, yeah. Okay. Yeah, sure. So the question was, what kind of software does E26 use, and can we exempt the course? The answer is they use SolidWorks, and you can be accepted from taking this course or any other course for that matter if you can demonstrate that you have taken an equivalent course elsewhere. But you need to talk to the instructor in charge and get approval from the instructor in charge.
And actually, all of our transfer students are exempt from taking E26, just as a practice, and just to give you a little bit more liberty in being able to achieve the high demand coursework that you have. However, some students do take computer-aided design in community college as high school students, and that's another way to also exempt yourself from that requirement. Does the mechanical engineering department do a lot of coursework or research in composite manufacturing? Dr. Roberto also answered that as well too.
Yeah, I can repeat. Okay, so the answer is yes. We have actually one of our new faculty members, Professor Grace Gu. She's an expert in composite materials, so she does both research, but she also has a new course that just got inaugurated. She unfortunately is not teaching it this semester, but she will subsequently, and it's a course on composite materials, and she does quite a bit of research in that area. So yeah, this is one of the exciting new areas that the department is reinventing again.
And I would also say another composite material is biological materials. So like tendons and ligaments are actually composite. So that's another way of thinking of composites and learning about them.
And we have some experts in that area. I can recall, let me think. Oh, yeah, Professor Grace O'Connell. No, just kidding. Of course, we have a lot of
the
experts
two
in
Graces
the area of there's a lot of work on biological materials, and we have some world experts. Among them, Grace herself. The two Graces are composite material experts on biology and aero.
All right, we have a question from Sean. Sean asked, Berkeley has a history of railroad engineering in the past and is wondering if there are any railroad related activities, classes / clubs today.
Unfortunately, I don't have any information on that. I don't know if Van knows anything about it. Do you recall, Van, if you railroad engineering right now, any clubs or courses?
I'm not aware of any clubs on campus that do that sort of thing. We do have different types of vehicle clubs. We have a human-powered vehicle, solar-powered vehicles, and also, I think, a low-mileage vehicle. But I'm not aware of any that connect directly to railroads.
Now, having said that, I think I think it's an area that should be coming back very soon, right? With all, I mean, railroad, as everybody knows, might end up being again a very important form of public transportation. So just because we don't have one right now, doesn't mean that you cannot create one club yourself once you get here. That's one thing you'll find in Berkeley. Everything is possible if you have enough time and enough energy. The one I would say the most precious commodity at Berkeley I found through all my experience here is time. There are always a lot more things that you can, and exciting things that you can possibly are going to be able to do. So you're going to have to budget your time and your effort, because there's always going to be a lot more things that you can possibly do.
There's also another question here about when and where we meet an advisor or academic counselor to discuss a plan on courses for a transfer student. This process usually begins in July. It's called Golden Bear Advising and Orientation. So you'll get a prompt from your central College of Engineering advisor around curriculum planning around that time. And just make sure that you're on top of your deadlines, because you're also going to be registering for 13.5 units all at once during that summer period. So making sure that you're available and reading through and absorbing all the modules is going to be important in terms of figuring out an academic plan that can best suit you. I'm also somebody who's available to answer any questions that you might have about your academic plan. And now that you know who I am, please feel free to email me and communicate any type of need that you might have related to student services. I'm here to serve everyone. And same applies for the same question for first years. You all will register around the same time as well too. The cycles are a little off in terms of like first years enrolling first and then second years, usually because first years are enrolling in classes that are like your math, your chemistries, your physics series. They get to enroll first because those classes are starting to fill up, and it's important for them to enroll first. But then transfer students will come shortly after that as well. So we have an undeclared student, Nola Bradley. Do you have any recommendations on planning your first year schedule? I would say to immerse yourself as much in the community as possible. The fact that you're undeclared within the College of Engineering is a very promising sign that if you do want to be a mechanical engineer, you will be able to, so long as you continue to make good academic progress. So joining different decals that are ME themed, participating in different clubs. A lot of our clubs have people from multiple disciplines and undeclared students in them. So just immerse yourself as much as possible, and feel free to email me as well too if you have any issues enrolling in our.
Let me expand that. I think he refers to maybe a curriculum, what classes to take, and I would recommend that take as many ME related courses as are as shown in our flowchart, right? So it's advisable that you try to take some of our courses, so that when you transfer to mechanical engineering, it will be flawless.
Exactly. Yeah. Like I was mentioning, if you have any issue enrolling in E26, which is the Intro to CAD, please feel free to email me. And usually most of our transfer students or undeclared students do not have, not our transfer students, I'm sorry, they don't have to take it, but our undeclared students don't have an issue enrolling in that course.
So let me just expand on it. It's a very popular class. I think, if I understand correctly, and Van can correct me. I think we might be offering that class, in fact, with online. So we might not have restrictions. Is that correct? Or I think our instructor has said that he actually wants to use
Which
Zoom.
class is that?
E26.
Oh, yes, yes.
E26 is going to be offered online, so there's going to be no enrollment issues. So almost everybody who wants to take it should be able to take it. And it's a very popular class and a very fun class.
Manra asked a question if it is advisable for ME transfer students to pursue a technical minor while still trying to graduate in 4 terms. Personally, I wouldn't advise it because it's going to be difficult to graduate in 4 terms just as a mechanical engineering student. There are certain things that you can do to take off a little bit of that load by taking courses over the summer. So this upcoming summer is an option for you to take a course like E29 or some of our upper division core classes. E7 is also being offered this summer as well too. Please look into our summer schedule to help assist you with that process. And also, I never really advise people on the things that, I think they can't do. I think people can achieve so many different things beyond what I can even imagine sometimes. However, just be careful around, what the demand is. And luckily, mechanical engineering gives you a pretty comprehensive and broad skill set that you can also dive into other subjects like biomechanics or doing mechatronics and other subdomains as well too.
Within mechanical engineering. And let me amend the question also, expand a little bit. A lot of students who have AP credits might be very comfortably be able to take minors. And in fact, we offer a minor within mechanical engineering department with an aerospace minor, which are a collection of 3 courses that if you take those 3 courses, aerodynamics, composite materials, and control of UAV, and you get a minor in aerospace. So that could be a good minor, for example, for ME students to take if they choose to do so. But as Ricky said, even within mechanical engineering, there are so many subspecialties that you will find that a lot of topics, robotics, materials, manufacturing, energy science and technology will also be quite interesting.
All right, there's a question that since there's a good amount of questions, I might be a little bit more brief with some, but I'm more than happy to talk to folks offline as well too, to dive a little bit more in more depth. But as a senior project, can you combine a senior project with something you're doing for a competitive team such as Formula SAE? The answer to that question is yes, absolutely. Could you please explain more about the differences between a joint and a double major? Those 2 terms are riddled by terminology and are a little bit confusing. However, essentially what a joint major means is it's a collection of courses that exist in 2 different disciplines combined to create one major. So for example, we have a joint major with nuclear and material science. And in those particular cases, students will take courses from both areas and achieve a joint major by the end of it. A double major is straight doing both the entire requirements of both majors. So doing all the requirements for nuclear, all the requirements for mechanical, and then you would have a double major. Sometimes you can do overlaps. So sometimes students prefer that option. However, a joint major is a little less comprehensive than either major would be purely on its own. How competitive is the 5th year MS program? I'd say that one thing that's really unique about the program is that it's competitive among our Berkeley students. So it's a smaller pool. You're not competing against the entire United States of people that are submitting applications. So in that sense, we do offer a 5th-year program for students that are excelling in our program to be able to have an extra year of academic coursework in order for them to have more leverage either in the industry or if they're moving on to go to apply to a PhD program.
Let me expand. We want to encourage our students. So as Ricky said, it's only open to our own students. It's not, I mean, you have to get good grades. So you have to, I forget what the GPA is right now. I think it's 3.6 or 3.3. I don't remember. I mean, you have to have a pretty strong GPA, but it's not overly competitive in the sense that many of our students actually do enter the 5th-year MS program.
Yes. So folks asked how to get involved with undergraduate research. You know, there's multiple access points to be able to be involved in undergraduate research. I would encourage everybody to go to research.berkeley.edu. Right there, you'll find different ways that you can propose research topics to either a faculty member. You can also find different ways that you can fund projects that you can approach faculty with, and different types of research programs that train you to initially start to become an initial researcher if you just want to get your feet wet. So that would be my recommendation to everybody, but also on a weekly basis or several times a semester, a professor will reach out to me to reach out to our entire listserv about different research opportunities that are open. And I do my best to facilitate those opportunities as much as possible.
If I could add on a related note, I often get a lot of undergraduate students directly emailing me when they know what lab that they're looking to get research opportunities in. So that's another way. Don't be surprised if you don't get a response your first couple of times, because faculty get a lot of emails. And on a related question, Guillermo asked about how to find out about the different research going on in the department. So I just put in the link for the faculty, and if you select on the individual faculty, you can get directed to their research laboratory. Or if you go to that website and you look to the left side of the website, it actually says by research area. So you could actually look at a sustainable tech and energy and then sort from faculty from there.
I think we should watch the time. I think some of our panelists have showed up. What time are we supposed to have the panel?
Yeah, we're gonna transition in about 6 minutes. So I'm going to try to answer 2 more questions. All right, so let's see. Jaded asked if you're undeclared, is declaring competitive or is it not a problem getting in? I think I answered that earlier, but as long as you have good academic standing, it shouldn't be an issue for you to be able to join the department as a transfer within the College of Engineering. All right, Shivret asked if, do you have any suggestions on what you can do to prepare before the school year starts? I'm more hands-on and don't have much experience with software, so anything will help. I mentioned this earlier about potentially taking a math diagnostic to know exactly where you're at. I think that that'll help you make a better informed decision. Staying in communication with your advisors, I think, is also important too, as they've been in, they've experienced a round of students on a consistent basis over several years. So they certainly can offer you some guidance on how to make the right decision or help guide you so that you can make the best decision for yourself. There's always the possibility that you can do some work over the summer. Chemistry gets offered over the summer. Math 1A gets offered over the summer. You could take them either at Berkeley or at a community college. That type of prep work is something that could always be beneficial if you're feeling a little bit nervous about taking those courses at Berkeley.
Even E7 is going to be taught, but that's a sophomore class, right? I guess that would not be a freshman class.
Yeah, that's correct.
So
So there's one more question here about academic opportunity for ME students to focus on a specific area such as sustainability and energy. Professor Carey, you want to take this one? You're our EST faculty.
Yes, I actually started to answer it in the chat here, so I'll try to complete the answer. Absolutely, there are courses that connect to this area that you can include in your program, and we certainly do encourage students to do that. Also, there's a number of faculty in the department that do research in those areas, so please do reach out to them and explore research opportunities in their labs.
And Ban, you can be you can tell you're very passionate. I think energy is going to be the big challenge of the next 10 to 50 years, and I think the department is going to go full blown on it, right? So
certainly they will if I can convince everybody to do that. But yes, it's a grand challenge problem to reduce carbon footprint and help preserve the earth from the climate problems. So we definitely want bright, talented students in our programs to take an interest and to work in those directions.
All right, we have 3 minutes left. I'm going to challenge the group, somebody to speak out loud. The first person to speak up is going to be the person that's going to be able to ask a live question, because we've been reading nothing but from the chat. So anybody want to ask a live question in the last 2 minutes?
Hi, I had a question about majors, and I was wondering if we were admitted into mechanical engineering, but also interested in exploring another major like EECS, if we could work that into our schedule somehow, and then if switching or like doing a minor in one of the two would be a possibility.
Yeah, I think it's all case specific, depending on where you're at with your placement in your math and sometimes your physics series. But the ME curriculum is pretty comprehensive, requires a lot of our students, and usually students have some capability of being able to pursue a minor. Double majoring is a little bit more rare, but pursuing a minor is certainly a possibility.
And transferring to X is actually hard. I understand, right? How hard is it to transfer from ME to X?
It's actually not as difficult as some people imagine, but it can be a little bit difficult depending on when you decide to do it. So the earlier you know about the information on how to do it, and the better position you have to be able to take the classes that you need so that you're able to do it. But sometimes people conceive of that idea a little too late. All right, I want to thank our leadership team, Dr. Roberto Horowitz, Dr. Van Carey, Carolyn Clark, and Dr. Grace O'Connell. This was an incredible presentation that I was lucky to be a part of and help facilitate. And I just want to thank our leaders and our students for participating. We're going to be transitioning into a panel, which is really exciting, where you'll actually be able to hear from people who were once in your shoes. And this is also a very exciting portion of our program. So please stay tuned right here as I transition and share my screen.
Thank you, Ricky.
Thank you, Ricky.
Thank you. Bye.
Thanks,
Bye-bye.
Ricky.
Thank you all so much.
Thanks.
All right. I am really excited to be welcoming our incredible group of panelists. I'm going to start off with Dr. Zanensky. Dr. Zanensky is a professor at Stanford, and she actually graduated from our mechanical engineering department with a PhD in 2007. Dr. Zanensky is an associate professor at Stanford University. She is in aeronautics and astronautics department. She's in the aeronautics and astronautics department. In addition, she's the PI, which is the principal investigator in the Extreme Environment Microsystems Laboratory. Her research interest includes the development of nanomaterials for extreme harsh environments, high temperature electronics, and robust instrumentation for Venus exploration. She hopes her work will help us probe and examine the hot surface of Venus one day. In the past, she held positions at GE Sensing, formerly known as Nova Sensor, GE Global Research, and at Hewlett Packard. She received an MS, like I mentioned earlier, and a PhD from our department. And she recently chaired the 2018 Women in Aerospace Symposium at Stanford University. She has served on the technical program committee for the International Electron Devices Meeting, the International Conference on Solid State Sensors and Actuators and Microsystems, and the International Symposium of Sensor Science. We'll give a nice little virtual round of applause for Dr. Zieninski right now. Next, we have Dr. Carolyn Chi. Very lucky to know Dr. Carolyn Chi very personally. We actually worked together in the College of Natural Resources. She is a rocket scientist. She specializes as a thermal aerospace engineer at UC Berkeley Space Science Laboratory, where she works on advanced satellite applications for interplanetary probes and Earth orbiting satellites. Her childhood dream was to become an astronaut, and it was her motivation for studying mechanical engineering. Dr. Carolyn, she's a triple bear. She received both her bachelor's, her master's, and her PhD in mechanical engineering in our department, and previously worked on campus as a researcher and an administrator. She's also worked for NASA's Jet Propulsion Laboratory, the McDonnell Douglas Space Systems, which is now called Boeing. And she has current and past mission projects that are very exciting, such as the Hubble Space Telescope, the International Space Station, the Galileo Jupiter, the Magellan, the Voyager, the Ulysses, satellites that are on Earth, tracers, Escapade, and some deep space weather satellites as well. On her spare time, and I can vouch for this too, Dr. Carolyn likes to play ball sports and look up at the stars with her husband and her 4 children. One of my great memories of Dr. Carolyn Chi is watching her play baseball outside of my office window during lunchtime. Next, we have one of our current students, Sine Jandio. She's a 4th year mechanical engineering student who has had the full breadth of the experience. She's been part of the ASME, which is the Association of Students in Mechanical Engineering. She's been part of Enable Tech, which is an assistant learning student organization and decal that's offered. She's part of the Society of Women Engineers and a member of Aero SAE. She's also part of our Equity, Diversity, and Inclusion Committee for the past 2 years. And she's also worked in the Fluid Mechanics Research Flow Lab. After graduating this spring, she will be one of our master students in our 5th year MS program. And she's also one of our fellowship recipients. She enjoys bike rides, drawing, and Indian classical dance. Let's give a great virtual round of applause for Sine as well. And last, we have Caitlin Gerthard. Caitlin is one of our former presidents in RoboBears and is currently an employee at Boeing. Caitlin is a graduate of our department. She is a transfer student who graduated from Orange Coast College. She's also a 1st generation college student as well. While at Berkeley, she competed in the combat robotics team called RoboBears, and she designed and manufactured a 3-pound combat robot. Later, she became the first woman to lead the RoboBears decal and competitive team. And she's currently working for Boeing's defense and space security, mentoring transfer students from her community college. And she's also part of our Equity, Diversity, and Inclusion Committee here at Berkeley. So I want to give a great welcome to all of our panelists for joining us today and for being such inspiring folks that we could all look up to and inspire to be just like. I'm going to start off by asking some of our students some questions. I'm going to start with Sine, and then maybe Kate could also answer this question also. But Sine, you are someone who had some cross-country experience. You came to California eventually, but what was it like for you to make a decision like coming to Berkeley? What influenced that process for you?
Yeah, so it was interesting for me because so I was born in Wisconsin in the Midwest. I grew up there, and I came to high school in California. I moved to California right before high school, and coming to California, which was pretty soon before actually coming to Cal, I found there to be a really huge culture shock because there was a change in demographics, in culture, and there was and change in climate, and then everything was also a lot more competitive all of a sudden. So I guess when I first got into Berkeley, I had mixed feelings because I was really excited on the one hand that I had gotten into a school like Cal, and I knew that there was a really good engineering school here. But I was hesitant because of what I perceived the culture to be. I thought it would be very cold, sad, detached, cloudy, and that I would be really lonely and away from my family. And honestly, I wasn't even sure initially if I wanted to do mechanical engineering because I had known that I was interested in engineering, but I didn't know what exactly I wanted to do with it or where I could go with it. So definitely it was a mixed bag of feelings. And then when I got to Cal and I spent a few months here, it was almost a 180 shift. And it was really remarkable when I thought about it, because I had gone from really dreading coming to Berkeley to really loving it. And I actually didn't want to go home after the first, the first weekend that I had the chance to go home. I said, I don't want to go home now. Yeah, so I guess my main takeaway from that experience was that my initial assumptions about Cal were thankfully wrong.
Good, yeah, I'm happy to hear that. That Berkeley truly did embody a place that you can call home. And like I mentioned earlier, we do consider our department to be one really large family. One that's imperfect, like any family, but one that strives towards perfection, and we try to be as precise as possible when it comes to being supportive and loving toward one another. I'm going to hand it over to Kate, who could also speak about the transfer experience. Kate, why did you choose Berkeley as a transfer student, and what was it like to be a first generation engineer?
Yeah, so I am a first generation college student. So when I got my acceptance letter from Berkeley, I was like, there's no way I can pass up this opportunity. Like, are you kidding? I got accepted to Berkeley. Like, I couldn't believe it. Surprisingly, I didn't get into anywhere else either. And I'm like, that's okay, because this is Berkeley. Of course I'm gonna go. And with that, I was like, this is my time to shoot my shot. I mean, and just try to take advantage of every opportunity that Berkeley had to offer. I honestly didn't know what to expect because I was like so nervous and so excited. I didn't know what to expect. But after going through Berkeley and, making friends that last lifetime, taking all these classes, I can honestly say that I'm a much stronger person after that, after just 2 years of going to Berkeley. I feel that I'm completely different than I was when I started. And honestly, I would do it all again because it was just such a great experience for me.
Good. Yeah, we're really happy that we can welcome our transfer students and be able to, facilitate an environment where people feel excited about the decision that they made and fulfill the promise of education that we have here. I'm gonna hand the next question over to Dr. Carolyn Chi. Dr. Carolyn Chi is a triple bear, so she's had 3 different experiences. But I want her to think a little bit far back in terms of like what were some of like the core elements that that you remember from being a student, and how those core elements, especially around doing thermodynamic work, stayed relevant to you throughout all of your years? Like, how did those early, challenges that you might have had with chemistry and some of the core thermodynamic classes end up being able to serve you in your career long-term?
First of all, Ricky, thanks for having me. I really appreciate it. And I'm welcoming all of you students that are potentially going to come here or want to come here. So one of the best parts of mechanical engineering curriculum is the breadth of engineering topics that you're exposed to. As an ME student, you'll be exposed to courses in thermodynamics, heat transfer, fluid mechanics, strength of materials, design and manufacturing. And it actually was in those upper division courses where I found what really interested me and what was intuitive to me and what I was good at. And that turned out to be heat transfer and thermodynamics. And that actually informed my decision as to what area of expertise I want to specialize in as I was graduating. I'd say what really prepared me for my work at NASA, JPL, Boeing, and now Space Sciences Lab was the course called ME 107, which I believe is now called ME 103. It's there that I learned to work in a team, incorporating all of the ME topics together for a common goal. And it is essentially where all the technical topics kind of come together and you can see how they are interdependent with each other and affected the total outcome. So working in a technical team and the ability to hear each topic's concerns or what they were for the overall project is important in real world application. So launching a satellite involves more than me just bringing my expertise as heat transfer and thermodynamics, but also hearing and incorporating and respecting the expertise from other people and concerns from many different technical points of view. And all those technical points of view are all needed for a successful mission or project.
That's a great answer, Dr. Kilichi. I appreciate you being able to walk. It's interesting how it seems like your memory just went back to when you were a student and you just walked us through the entire curriculum and how that, how you're able to apply it in your everyday life, which is pretty amazing. I would say that, personally, I'm also a Berkeley alum as well. And it is pretty often that I like stop and reflect on what I learned at Berkeley and how I'm currently using it in my current role. That happens more often than not. And it really does drive your core memories. And for me, it actually brings a great sense of fulfillment, a great sense of happiness to be able to know that my education, although it was difficult, it meant something and it continues to mean something. So thank you for sharing that, Dr. Chi. Earlier, we had a question about research, which I think Dr. Zanetsky can help assist with and answer. And she was really fortunate enough to participate in a research program with Dr. Kazerouni as an undergraduate. And I'm just curious about how that research experience helped solidify your path and put you on a course to want to be a long-term researcher, but even just a graduate student, and when that was in the most immediate future for you?
Yeah, good question. Yeah, so I'm going back to the summer of 1999, and I was an undergraduate at USC in mechanical engineering, and I saw a flyer on campus that said, spend a summer at UC Berkeley doing research. And I had spent time at Berkeley because my cousin worked in Berkeley downtown on Telegraph Avenue. And I was just always so fascinated with the city of Berkeley. So I jumped for the opportunity to spend a summer there. And I ended up matching with Professor Kazerouni, making a teeny tiny walking robot. And I worked closely with a mentor, which was a graduate student in his group. We worked closely together every day, doing modeling of the gait, the walking motion of the robot. And then at the end of the summer, we actually fabricated the robot using the machine shop in Echeverry Hall. And so it was a really, really fun experience. And I'm a first generation student. So You know, getting a graduate degree was pretty foreign to me. And so doing research in Kazaruni's lab really solidified that for me. And he also wrote a letter of recommendation for me to, you know, cultivating that relationship helped me get into various graduate schools. So I highly recommend using the opportunity to get into the research labs.
Thank you, Dr. Sinetsky. Yeah, I think that that's a question that's on everybody's mind. Even though like students are just entering as first years, I think they're already starting to think about, you know, different ways that they could be long-term scientists. And explaining your research experience, I think gives people, you know, that a bit of that planned happenstance that happens when we're just looking at a flyer or coming across some message board that really gets us going about you know, what our potential future is going to look like. I'm going to ask a little bit about like the cultural amenities. I know we've been talking very academic in these early parts of our conversation, but I'm curious about what people's housing situations were like. I know that housing in the Bay Area is something that sometimes is riddled with a little bit of mystery, but I'm curious as to what, and I'll ask everybody to answer this one, is just what was your first housing experience like, and what was it like learning to work with other people in your household around you know, the everyday practices of like, you know, setting healthy boundaries around studying and doing leisure activities with them.
I can go first if you'd like, Ricky.
Go ahead.
Okay, so the first year that I was at Cal, I stayed in the Stern, it's the all women's dormitory. And I can tell you that I did not have a positive experience. Though the food was fabulous and the accommodations were really nice, I felt like it was a bit isolating being there on top of the hill and so very close to just the technical community. So you had it right across the street from the EECS and also from by the mechanical engineering and civil engineering. So I didn't feel like I was getting that exposure to diversity of thought throughout campus, which I really came to Berkeley for, right? So I wanted to experience being exposed to people who had different thought processes from the humanities and social sciences. And then, but being in Stern and so close to the north side, I didn't feel like I got that. Now I fixed that the second year by getting into the dorms of Unit 1 and going, that's the 8-story dorms. And there I felt like I was more part of a Berkeley community and I got more diversity of thought. So my experience in the units was much more positive, though the food was not as good as it was at Stern.
I could definitely comment about that as well too. I'd say the Stern, Bowles, what's the other, the International House, the I House, and Clark Kerr tend to have better food than but in terms of social amenities, it might be a little bit better in the unit. So I think it tends to vary, but thank you for sharing that perspective, Dr. Chi, I appreciate it. Sine, you want to take that question too?
Yeah, sure. So I started out as a freshman in the dorms in Unit 1, and I was actually, if any of you are familiar with it, there's a Freeborn Hall, which is a substance-free dorm. I was in that dorm because, I really enjoyed my experience in Unit 1 because I did feel like there was a really strong community there, and I got to connect with a lot of the people in that building and in and around the unit. There was a nice like little academic center at the base of the building. And through that experience, I also learned how to live with roommates and manage my schedule in a way that I hadn't really experienced before that. So it was a very interesting and educational experience. But then I actually moved to an apartment the next year, and then a semester after that, I moved back home. Just to sum it up, I have had I've moved around a lot during college, and I've actually spent probably more time living off campus and commuting than I did on campus. And so maybe one thing I can say about that is it's it's really nice to live on campus, to have access to campus resources. So I would say if you have the chance to do that, I would encourage it. But when I was commuting, it was definitely challenging because at one point I was, going on BART for like 3 hours a day, and it wasn't the most manageable. But I will still say that if you have to do either option, depending on your circumstances, I think Berkeley is a place where you can still manage that. It's okay to be on campus, and it's also okay to not be on campus and have to commute. I would say my experience with housing was overall positive. I did enjoy the dorm experience and the apartment experience. But yeah, I just want to give a bit of my my journey through housing.
Dr. Zanansky, do you want to talk about your housing experience?
Yeah, I can chime in. As an undergraduate, I spent a summer at the iHouse, which was super fun. The food was pretty good, fine in the beginning, but then, I think anywhere you live, you kind of get tired of dorm food. So I was using my small summer stipend to eat out in the, guess what is it, the little Asian
Food court.
The food court on Telegraph Ave, the Asian Ghetto. That's right. Yes, Asian Ghetto. So that was always fun. And then as a graduate student, I lived in the Gourmet Ghetto. Which is, you guys should go and experience. They're Berkeley's great for food. There's cheese board, things like that. So as a graduate student, you get paid a little bit more. And so had a roommate, which I met on visit day. And so we decided to roommate together. And that was a lot of fun to live off campus and experience that life as a graduate student.
Kate, do you want to share your housing experience?
Yeah, so I got really lucky with housing. My first year, I lived in Martinez Commons, and I got into a floor specifically just for transfers. Like, you had to apply and prove that you were a transfer. And from that, I got a really cool community that was all transfers, and everyone was a different major. So it was really nice to have just that floor of people to start with, even though they're not going to be in your classes. And it's nice to have a break from like your classmates and come home to someone who's like completely different energy, compared to like the engineering energy when everyone's like tired of studying, and you come home to all these like other people with tons of energy, and it's really nice. And then my last year, I got into some apartments, some really nice apartments that were brand new. I think it's called Nexus. But yeah, they were brand new, and I think that was the first time I had to cook on my own and come up with some recipes. I definitely ate out more than I did because I didn't know how to cook or had time to cook. So I would suggest learning how to cook and putting together some meal preps before you move into an apartment. But definitely, I think I highly suggest that you also go to Cheese Board if you can. It's just like the thing to do. Go with your friends, go have some fun. Definitely go do that.
Yeah, absolutely. I think fun is a very important element to success at Berkeley. There's a lot of different ways that students engage with fun, sometimes through the extracurricular experience. My next question is going to be about engaging in the extracurricular experience, student organizations, projects that exist outside of the academic experience, but also just like the mentorship that comes with those types of projects as well. I know that some folks that are in our audience might be first generation, either college students or first generation scientists or first generation engineers. And sometimes you lean on an upper division student or some type of mentoring from folks that are already in some of these organizations. So I think a good question could be like, how do you transition or break into a student organization or a particular research project or any type of extracurricular experience and learn from the people that are already there while at the same time making contributions. Sine, would you like to comment on that?
Yeah, sure. So I think like Ricky mentioned, I had experiences, so far I've had experiences in the EDI committee and in ASME and SWE, as well as Aero SAE recently. And I think for me, I really tried to make the most of whatever opportunities came my way. So throughout undergrad, I kept an eye out for things that I thought would enrich my experience. And I just kind of applied to everything. I talked to as many people as I could. I kind of just wanted to make sure that I was getting, I was, you know, that Berkeley has so much to offer, and I was not just sitting and kind of following the track, but I was actually like branching out and trying out different things. And through those experiences, definitely, so I got involved in those experiences because I felt a really strong sense of school spirit. I really love Cal. And I specifically joined the EDI committee because I wanted to help make the department feel more homely, you know, for students who might not feel so at home. I wanted to help create a space for students who might have been, you know, marginalized otherwise, and also to help me get involved in volunteering, which is very enriching. And then with ASME and SWE, it was just, again, another way for me to feel connected to the department and the College of Engineering. With SWE, I got exposure to how to, you know, the importance of advancing women in engineering. There was, I also found communities in all of these places. So it wasn't just about helping me feel connected to the community, but I was also, or helping me contribute, but I was also feeling connected to others. So I hope that answered the question. Please let me know if there's something I didn't address.
No, that was great. And I would definitely welcome some other perspectives from our panelists concerning some of their extracurricular experiences that they've had. Dr. Carolyn, you want to think back to some of those experiences?
Sure. So as you mentioned, Ricky, I'm really into ball sports. And I also mentioned about how I was in undergrad, I was at Stern Hall, and I was craving that diversity of thought. And so I sought out not just the technical part, but the fun part of the community of Berkeley. And that was kind of bringing together my love of sports, ball sports, and then meeting that diversity of thought. And I found that actually through intramural sports. And so now it's not technical, but you know, some of the teammates that I had on there were other mechanical engineering. So we had a mechanical engineering team, but we played other people throughout the community, the campus community in these other games. I played basketball, I played softball, and it was a lot of fun. And I found that to be a huge relief from all the stressors that you're going through with the 16 units that you're taking. I mean, you really need a break from it all. And I found that to be a wonderful release for myself.
Excellent. How about you, Dr. Sininsky?
Yeah, just piggybacking off of Carolyn's comment, Berkeley is a beautiful city. So for fun, what I would do is take walks and hikes in Tilden Park. There's also the steps of Berkeley, really interesting paths that are around the Berkeley hillside. Indian Rock Park. So there's, and then beautiful bay views that you get to see from many of those locations. So recommend that, and just seeing what the entire Bay Area has to offer. I fully agree, take breaks. You guys are going to have all-nighters, doing homework, reports. That's just the nature of engineering. It's super hard and challenging, which is what we want and what we like, right? We want to be challenged, but at the same time, taking the time to decompress is really, really important. And the Bay Area has a lot to offer. Also, as a student, just, you know, organizations that also can help you with opportunities to network, Society of Women Engineers, National Society of Black Engineers, SHIP, Society of Hispanic Engineers. There's so many groups. Don't be shy and participate, because those can line up internships and opportunities to travel and go to those national conferences associated with them. Those were super fun. I really enjoyed those as an undergrad too.
Awesome. And Kate, you had the opportunity to be part of a very formational part of a student organization that also was a decal, provided, you were actually providing the extracurricular experience for our students by facilitating a course, which was student-led and mentored by a faculty, but mostly run by students. Can you describe what that experience was like for you, and how students are able to break into that and get an opportunity there too?
Definitely. So my club, RoboBears, offered a student-led course. It's called a decal. And basically what we did is we taught our club members to design from scratch, manufacture with your own hands a 3-pound robot. And with that, when you completely build it, you get to compete with it. You get to compete against other schools, people who do the hobby, and it's so much fun. So basically we offer like these skills, building something from scratch and then just holding it, manufacturing it with your own hands, I think is just the best experience I've ever went through at Berkeley. It's just something that classes don't offer. And it's just so great to see my my students go through that. It's very fulfilling and it's very fun just to see it in action and break and, getting to fix it again is just so hands-on and such a different experience. And I'm really glad to offer that to my students.
Great. Thank you for sharing that, Kate. I really appreciate that. I want to get a little bit more academic, or at least space heavy. I'm curious, I'm feeling a little dated because we've been talking about Mars a lot, like in the department, but Dr. Zanensky talks and researches Venus. So I'm curious, are we gonna make it? Will I be safe? Let me know what's going on in Venus. I'm curious what the exploration is looking like, and what type of work you're doing on a day-to-day basis to ensure that we can make it.
Yeah, I'm very excited that, there is going to be a major in aerospace engineering at Cal. So that's very exciting. And I shifted fields. All of my degrees are mechanical. And so when I joined Stanford as a faculty, I switched to aeronautics and astronautics, or aerospace engineering, and built a lab focused on extreme environment electronics. And so Venus is our neighboring planet. The surface temperatures are 480 degrees Celsius, so that's super hot. The pressure is 90 bar. The atmosphere is chemically corrosive. I'll switch to my Venus background here. So this is the picture of, you see this crusty surface and this the sulfuric acid atmosphere. So we want to put a lander there and take a picture. And because it's such a harsh environment, much like a combustion environment or some of these really harsh earth-based energy environments, such as downhole applications that were discussed earlier, the technology has to sustain this harsh environment. So those are some of the things that my group looks at, and it certainly translates to technology that would be based on Earth as well. So it's super fun. I had no idea my work at Berkeley would lead me here to this path, but it's been super, super fun.
Great. How about you, Dr. Carolyn Chee? So I think I read somewhere that your signature or your name is out there orbiting in space, and I'm just curious about what that project was like for you and what's going on in the space lab, just right up the hill from where the students will be taking classes.
Well, okay, to answer your question about my signature, it is actually orbiting around Mars and Jupiter and Saturn.
Oh.
Yeah. So the deal is when I was working at JPL is if you did something significant for the project, then you could sign the bird, as they call it. And so I signed my name on those birds, and they are now orbiting those planets. And the current, my understanding too, that is also something that the Space Sciences Lab does. So my birds that will be going up in a year or two, I'll also be able to sign.
Nice.
So
Really-
I'm sorry, what was the other question?
Well, the second question was if you could just share a little bit more detail about what those projects are like in the Space Lab. I'm just curious to see what's going on up there, what type of work researchers are doing, and all. And are there any undergraduates that orbit that space?
Actually, there are undergraduates that the Space Sciences Lab is looking for. So if you're interested in all, I encourage you to email ssl@berkeley.edu and send your resume, and then see if there's any PIs that are interested in picking you up to do research in their labs. Some of the neat things that we have going here are missions that are going to Mars, like JPL is doing, but we also have ones that are going to Venus, like Dr. Sininsky. And also my most recent project is actually called Fuego, and it is going to be studying the wildfires in the world. And in particular, it started as a California mission, but with the wildfires in Australia, they became more interested and fronted the money more quickly. And so now we are making that mission to go study the wildfires in Australia.
Awesome. Yeah, it seems like you're circumnavigating a little bit back to your mentor, Dr. Carlos Fernandez Peyo.
Yes,
with
he's a
little bit of
wonderful
some
guy.
lessons.
Wonderful guy. I can't say enough about Carlos and his influence in my positive experience in the mechanical engineering department.
Yeah, that's actually my last question for our panel before we have our audience ask questions, but it really has to do with mentorship. What's one solid piece of advice that you would give an incoming first year student, something you wish you would have known on day one that can help guide them? This could be maybe a reinforcing thought for them as they enter the school. Just some good piece of advice.
I can say that my number one tip is go to office hours, which I think a lot of people say, but it's a really important one because I feel like the best way I found guidance and advice and informal mentorship was through office hours, just for class and asking questions about the material. And sometimes I get guidance about other things, and it just helped make everything feel more connected, especially in a place like Berkeley where there are thousands of students, and it can be easy to get lost in the crowd and feel like you're just one of the masses. But I think going to office hours really makes you an individual, and professors are really nice in the ME department. And yeah, like I had said before, I think
Sorry about that.
taking advantage of all opportunities is really helpful. And again, for like finding that mentor, you never know who you could find or where you would find them.
I can go next. I would highly suggest joining a club to help you develop your technical skills, because sometimes classes will teach you, they'll teach you the theory and the basics, but you never really apply it until you join a club. And from there, you can make so many friends, you can meet some mentors along the way. It's just an experience that the classroom doesn't offer. And on top of that, it's just a break, a break from your classes. Mental health I feel like is really disregarded when you're taking your classes. So I think you really need to step back take a break, go have some fun, even if it's like going out and getting some pizza or something. Just take a break.
I can go next if you'd like.
Go ahead, Dr. G.
Okay, so the one thing that I would stress is the mental health aspect and taking care of yourself and remembering to, you know, if it's joining a club or going for a hike or playing intramurals, that you do it and you find it soon. Because the 16 units that you're going to be taking per semester is going to be unlike any 16 units that somebody else on the campus is going to be taking. But I think one pearl wisdom that you should go in with is knowing, because right now you are all at the top of your high schools, right? You're all very smart cookies. But the one thing to learn is that you can't get through Berkeley alone, that you need to learn from others and with others. And that will only not help you here, but it will help you when you go out and work.
Great piece of advice. Dr. Zielinski, you want to round us off before we?
Yeah, I agree. You have amazing resources on your amazing campus. You guys are the top of the world, right? And the faculty around you are world class. So pick their brains, learn, ask questions, work with your amazing peers that are excited to solve the next generation challenges of our society, right? And what are the problems that you want to solve? You have everything at your disposal on campus, in the Bay Area, in the world around you. You know, you're a Berkeley student, you can email anyone. Most likely you'll get a response. They'll see that .berkeley.edu and, oh, okay, yeah. You know, so utilize that, and it goes by quickly, so enjoy it. It will be hard. Go to office hours, ask questions, sit with the material. It's really important to have those fundamental skills so that you can go off in industry and really have a strong foundation. So that's, I know it's a lot, but that's why you're here. So, yeah.
All right. Well, you know, I think that everybody had some really solid sage to offer to our new incoming class. And I want to encourage our incoming class to, turn your cameras on and ask questions live. I know that there's some questions in the chat, but I certainly want to prioritize people who want to speak out loud and share a question with our panelists. So feel free to ask your questions.
I have a quick question.
Go ahead.
I was wondering, like, if you're a mechanical engineering student, how easy is it to take courses through Haas and like the other kind of schools?
Yeah, so I could answer that question as the advisor. It's actually a little easier to get into a Haas class as an engineer than it would be as maybe like some other mainstream student in the College of Letters and Science. And the reason is because sometimes Haas students or Haas professors are looking for a scientific background to complement their entrepreneurial idea. And they welcome the diversity of thought by having an engineering student. So just make sure to, reach out to those faculty members. Usually Haas classes are small, and Haas professors tend to have a tendency or the power to be able to like handpick somebody out of a pile and just put them in a class, which is like not very common among other disciplines as well too. So that's a positive for engineers. I will say that the early classes, like the larger survey classes, like intro to business administration, will be just as hard to get into as it is for anybody trying to get into the Haas School of Business. But if your goal is to just learn about a specific niche business concept, then it's totally possible. We also have a discipline or a major called Industrial Engineering and Operations Research. and they do these entrepreneurial challenges and courses that exist that can also provide you with a little bit of the insight that you might be looking for as an academic experience.
Thanks so much. As a quick follow-up, I was wondering, like, is it possible to get a double major between Haas and engineering, or get a certificate or minor from Haas?
I'm not entirely sure what their certificate offerings are. I do know that double majoring is pretty difficult given the demand of mechanical engineering, but not impossible. We have had double majors in the past, and you do have 2 opportunities to apply. So fall semester of your sophomore year and fall semester of your junior year. And basically it's a large application pool, so you apply when you're ready. And it's its own individual process, unlike, it's a different application cycle that you have to engage with.
Is that for MET?
No, MET is something that you are offered or you apply to as a secondary student.
Mm-hmm.
Applying to the Haas School of Business would be like as if you were applying like just any other student.
Oh, okay, right. Got it. Thanks so much.
You're welcome.
Hi, I wanted to ask real quick. So what resources do we have like in terms of like workshops or like tooling shops or wherever we can like find a bandsaw or something? Like what locations are there on Berkeley's campus where we can like build whatever we want? Like I've heard of Jacobs, but are there any other locations too?
I'll let the students answer this one too, since they could give the firsthand experience.
I can give my input. So there's Jacobs, which is open to some students who sign up for the pass. You might get it for free through clubs. So that's like the primary where everyone goes to, the easiest to get into. Jacobs offers a metal shop downstairs, which they have a whole bunch of machines down there. They also have a wood shop where you could work with wood. And then the next thing is the ME machine shop. It's actually, I don't know how hard it is to get into, Ricky, but I believe from when I was there, you had to be in a club to go in there.
Yeah, we're trying to make it a lot more inclusive for our machine shop to be accessible to our incoming transfer students in particular, because now we're attaching it with a course that students have to take. And by taking that manufacturing course, it's also implies that you're going to do machine shop training. Once you have machine shop training, then you can have access to the machine shop. There's also different places where students build alongside their student organization. So the Richmond Field Station is also one of those locations as well too.
I can just add that there are a couple other maker spaces on campus also for people who just want to prototype things. There's an invention lab in one of the buildings. There's also a Moffett makerspace, which is in one of the libraries. So there are different things outside of the ME department too.
Yeah, I believe there's one in the physics department as well.
Yeah. And also, I'm not sure, Sanaya, you may have mentioned this, but also in the College of Environmental Design. So if you take a class through architecture, you may potentially have access as well too.
And on the micro and nano scale, there's the Marvell Nano Laboratory over in Sudarchadai Hall. And if anyone wants to make tiny things, chip scale or nanomaterials, that's can be interesting as well.
Cool, thanks. I also had like one more question. So about like the 5-year BSMS program. So is that really hard to get into? Like, what are the base requirements and stuff to like do that 5th year?
It essentially means excelling in your upper division coursework. Most people who are strong applicants for that program have done pretty well in their core courses that are 100 level or above. And that usually tends to lean towards like a stronger application. Also, having a really strong built relationship with a faculty member who can write you a letter of recommendation is important. because, you know, the network is clearly small, right? It's our faculty are involved with the decision-making process, and, you know, they value the, you know, the opinions of their colleagues, right? So having a good relationship with a faculty member tends to, you know, facilitate a good letter writing campaign that students engage with. And usually having 3 strong letters from core faculty member, you know, it points to, it signals towards being a strong candidate in that department.
Yeah, I was wondering, does the university offer any support to new startups or projects for undergrad?
For projects?
Yeah, like startups or...
Oh, for startups. Yes, so there's actually a few that I know of, but I think I'll let the students also comment after I answer the question a little bit. There's the Big Ideas project that happens every single year. The Fung Institute also supports students who have entrepreneurial pursuits as well too. And sometimes it becomes like multidisciplinary in terms of having people from multiple fields come together for a particular idea that they're coming up with. So there's the Big Ideas, the Fung Institute, and then maybe students can comment on any other entrepreneurial ideas that you may have heard of that support startups. And so I could also comment that our faculty are actually engaged with a few startups, Dr. Kazaruni being one of them with his exoskeleton projects. I would encourage you to sit with our faculty to talk to them about what type of work they're doing, either in assistive technologies or in the biotech industry as well too. So kind of keep those names in mind, Dr. Kazaruni and Dr. Kivney.
Yeah, thanks.
Good to see you again, Francisco from Chile.
Yeah.
Me acuerdo.
Yeah.
All right. Anyone else have a question? Again, we're prioritizing people who want to speak up and give a question live.
As a quick follow-up to Francisco's question, I was wondering, like, how easy is it to work on personal projects outside of the classroom? Like in maker spaces or like with professors and stuff.
I'm not sure what, like, I think you're probably talking in terms of like regulations or people wondering like, you know, how much material could you use that's Berkeley related to a particular class, or how much can you do on your own? I think there tends to be more flexibility in Jacobs, but it really just depends on like, sometimes even the personalities of the people involved. There's some people who are very supportive and want to like, you know, kind of help people pursue like their outside interests. And there's other folks that want to kind of ensure that whatever you're working on is course based or related to a class, because that's where some of the funding for the materials might be coming from. I'm gonna let Divya ask a question since she turned her camera on, and I think she wanted to ask a question.
Thank you so much. Just a small question. When we sign up for classes, is it difficult to get into those required classes for MECI or to get the classes that we want because of class sizes or whatever?
I'll let the young alum and current students answer this one too.
Oh, well, I would say don't do what I did, which was not realize that there is that classes are time sensitive, enrollment is time sensitive. So my freshman year, I did not know that. And I actually got into all of the classes I wanted. So even though I wasn't aware of, you know, having to sign up on time, I still got into the classes I needed. So I would say it's probably not that hard to get into your required freshman courses, but I think Kate should probably give her input.
For transfer students, it was very easy. I think I got on the wait list a few times, but the thing is, the first 2 weeks of class, so many people are switching around their schedule and dropping and going to different times. So like, there's a very good chance that you will get into what you want.
Yeah, I definitely second that. Somebody who helps facilitate the process a little bit. I'd say our engineering students have reserved seats in a lot of our core classes, and it really isn't as much of an issue as it is outside of the department. I will say that if you're interested in a specific niche subject that's like very popular, do your best to just be attentive of your enrollment time. Like for example, if you want to take a reading and composition course in, let's say, you know, some people like taking those courses like in film or in German, which they're not taught in those languages, or it's not all about film. It's thematically based in those subjects, but they're writing courses. Then those tend to be a little bit more popular than the course that's just called English 1A or College Writing 1A. So just be mindful of that. And there tends to be a popular course or 2 or 3 or 4 that everybody's trying to get into every single year. And some of those are like Robert Reich's Wealth and Poverty course, Alex Filipenko's Intro to Astronomy. Those types of courses tend to have like a huge following. So just be aware of that as well too.
Ricky, I just thought of something that I wondered if I could circle back on Francisco's question about startups.
Yes.
So Francesco, I remember, I know that there's something on the campus called Skydeck, and it is a place where it's a startup accelerator and incubator program for students, faculty, and staff on campus. So you might want to look into that.
Okay, thank you.
And just to add on that front, syncing up with the various laboratories on campus that have technical areas that have synergy with the areas that you are interested in pursuing would be to your benefit. Again, don't work alone. Find the expertise that you have around you, the network that you have around you. So that could be a strategy. Spend some time cultivating relationship with the lab that might help accelerate your work as well.
All right, we have time for one more question, and we're certainly looking to prioritize somebody who hasn't spoke yet, and also someone who just is really eager to ask something. We're hoping that in these next 2 minutes, we could provide you with an answer. Anybody out there have a burning question? How about you, Megan? Hopefully you're still with us. Or anyone else. We have 2 minutes left with our incredible panel.
Yeah, I would like to ask you, Debbie, how was your experience working in XLab?
Oh, in the XLab? Yeah, that's my lab that I started when I became an assistant professor. And so this lab really came out of my PhD work. Again, the work that I did as a researcher at Berkeley, I was developing extreme environment materials and electronic devices for space. And then when I graduated, I went off and started my own lab. And so that's what we work on there at Stanford. And then we get to come back and also share stories here at Cal as well. I'm also on the advisory board of the ME department, and collaborate with faculty at Cal. And I also have mentored students. Students have come to my lab in the summer as well. So.
All right, I want to thank our panelists for giving all of the great wisdom, advice, sage. I'm so grateful. Any opportunity I get to learn from our students is an opportunity that I jump on, and luckily I'm able to participate in Cal Day on a year-to-year basis. And for me, you know, as an alumni, it definitely is a reflective period when I get to re-engage with what it was like to get into Berkeley and re-celebrate. You know, that's something that always comes to mind around March 31st. Just thinking about how excited I was to be part of this particular community and how I'll continue to be part of it forever. I think that's something that is unique to the Berkeley experience, is that once you're a Golden Bear, you're a Golden Bear for life. So thank you to this incredible panel for all your hard work and commitment in all your respective spaces, but also for the service that you did for our department and coming back and presenting. I really appreciate it.
Thank you, Ricky.
Bye,
Thank you,
everyone.
Ricky.
You.
Thank you very much.
Thank you.
Thank you. Have a good one.
Bye, Sine.